In this series of videos, we're going to discuss various applications of definite integration. Our first application is going to be one of calculating areas enclosed by curves. Having studied integration so far, we already know that how to calculate the area enclosed by a curve and the x-axis. So for example, if you're given a simple curve and let's say some curve f of x, and we intend to find the area enclosed by the curve and the x-axis, we know that we can just do this very easily by evaluating the area, or rather evaluating the integral uh, of the function f of x with respect to x within the limits a to b. Okay, so we can use this idea and very easily evaluate or calculate the area enclosed by two curves. So let's take two curves. Let's take we have some curve f of x and another curve, say g of x, and that these two curves they intersect at say various points a, say B and C. Okay, and we are interested in finding the areas enclosed by the curve. So first, let's find this particular area. Let's call this region R, and let's calculate this area. Okay, now from the definition of the integral, we already have a few, we know that solving this problem is pretty straightforward. What we'll do is we can find the area of this red region, which is the area under the curve f of x and the x-axis within the, for this interval a to b. And then what we'll do is we can repeat this idea and calculate this green area, which is the area enclosed by the curve g of x and within the x-axis within the interval a to b. Okay, so the area that we're looking for, okay, which is the black shaded area, is simply the difference between these two areas. Okay, so the area of region R, we can say, is equal to integral a to b f of x with respect to x, which gives us the area of the red region, minus integral a to b g of x with respect to x, which gives us the area of the green shaded region. And we could rewrite this as integral a to b f of x. Okay, hold on, I just want to make sure we don't get confused here. F of x minus g of x, everything with respect to x. So this would be the area of region R. On the other hand, if we say we're interested in finding the area of region, say S here, okay, where the function g of x, you know, is the upper function and the function f of x is the lower function. So we can use the same idea but with one slight difference, and we could write this area essentially as integral, say b to c, the function g of x with respect to x, minus b to c f of x with respect to x, because clearly the area under the function g is the larger area in this particular interval, and we can rewrite this as integral b to c g of x minus f of x with respect to x. So this gives us the area of region S. Now, in a situation, let's say you're told to find the area enclosed by the two curves within the interval, say A to C. So if you want the area, okay, within the entire interval, say A to C, okay, here we have to be careful how we set the problem up, because basically we know from these two parts what we need to do, but it would be a mistake to simply write this as the area from A to C f of x minus g of x with respect to x, because this would, we could use again properties of integral, split this up into two areas, which would be integral, say a to b f of x minus g of x with respect to x, and then plus integral b to c f of x minus g of x with respect to x. But clearly we see that this part, okay, would be a negative number. Okay, so if we were to try to evaluate this area using this formula, then this would be we'd have the wrong area. So this would be the incorrect way of doing this. The correct way of finding the area for this would be to recognize that, hey, for a particular interval, one function is the upper function, and in another interval, the other function becomes the upper function. So we can split this up as integral a to b f of x minus g of x with respect to x. And then for the interval b to c, we would have g of x minus f of x, and then with respect to x. And this would give us the correct area, because we know now that this would be a positive number, and this would also be a positive number, and we would have a correct area. Okay, so hopefully this clarifies the ideas about how to set up the problem, and in the next video we'll apply this idea to calculating the area enclosed by two curves, and apply these situations. Okay, hopefully this helped.